Consult's YouTube channel, and in this video we're gonna continue our topic that we started in the last video all about solidity and blockchain programming. And in this video we're gonna talk about Ethereum, and before actually jumping right into coding and learning how to code using Solidity, how to create our first decentralized applications, before doing that I do kind of feel like we haven't said everything about Ethereum accounts, how to create them and how to transfer with those contracts, what type of Ethereum accounts are there possible. So we'll continue talking about this a little bit more in this video, and from the next video we'll actually start already our long journey in Solidity and decentralized applications. So with that being said, without further ado, let's jump right into it and see what we have prepared for today. So what we didn't say in the last video and worth mentioning in here is that Ethereum accounts can be like two types of Ethereum accounts are possible. All right, so the first one is externally owned account, short said like EOA, and the second one is contract account. Okay, so only these two types of accounts are possible. Now the ones that we have been creating in the previous videos, like in the MetaMask, or if you download any private wallet, create an account there, these accounts are all called externally owned accounts. Okay, so those accounts are controlled by a private key and are identified by a unique address. All right, so it holds an Ethereum balance and has no associated code. It's being used for holding, sending, receiving Ethereum, and interacting with smart contracts as well, like deploying them, calling functions on them. So for example, if you want to create an account and send some funds to me or receive some funds from someone, then you create a wallet address like account, Ethereum account, and using MetaMask or any other solution that you want, like any other wallet that your preferred wallet, and that's it. That's externally owned account being used for certain purposes, such as holding your Ethereum, as I said, sending, receiving, etc. But there is a second type of accounts, and those type of accounts are what decentralized applications are based on. All right, so those accounts are called contract accounts. Okay, so contract account is a smart contract accounts which are written in Solidity that we're gonna learn in the future videos. So these accounts are also a type of like Ethereum accounts, yeah, but they are controlled by code. All right, they are controlled by code and they have a unique address that doesn't have a public or private key, unlike the first type. Yeah, it's an autonomous agent and its code execution is triggered by receiving a transaction or a message from another contract of an externally owned account. It means that, for example, if you use your externally owned Ethereum account, yeah, your account, and then you write a smart contract, and then you use that account to deploy this contract onto the blockchain, yeah, possibly maybe you are creating an application, a decentralized application, and you are writing down this smart contract, and then once it's on the blockchain, okay, so it's being controlled by the code that you wrote in that contract, and you can use the address as an owner of that contract, okay, that address that has deployed that contract, you can use that same address to interact with the contract, to read some information from it, to send some information to it, okay. We're gonna, of course, talk about this in the upcoming videos, how to call the functions from the smart contract, how to send information into the contract, and some functions, not only the owner, but also its public functions, so if anybody else can interact with it. Once your contract is up and running on the blockchain, anybody can interact with it. So whatever is important in here to remember is that once contract is created and deployed, it's controlled by the code that the creator has written in it, okay. And then using those externally owned accounts, you can interact with the smart contract for various purposes, okay. Maybe you are a hacker and you want to hack it and take the balance out of it, okay. So this is also possible, but I don't recommend you do so, even if you can. And of course, it like an externally owned account, those contract accounts, they also have Ethereum balance. So you can also they can also keep balance within them. Then they can transfer balance to another contract or to another externally owned account. Okay, so from your personal wallet, you can send money into this contract account and you can withdraw money from it. For example, there are lots of applications, decentralized dApps, that you put money in it, and then after some time passes, you can withdraw your money from it, maybe with some together with a profit. Okay, so these are the contract accounts. Okay, the smart contracts, which again, very important, are controlled by code. Okay, so once they are deployed, depending on the code is written there, they perform that way. Okay, according to the code that creator or creators have written. All right, so we'll go through it in details later on. And then we come in here. It's important to note, guys, that the private key of externally owned account, it grants the custody over the funds associated with the account. All right, so if you have the private key, you are the owner of the funds. Okay, you can do whatever you want, and that's why it's very important to keep your private keys for yourself, not to expose it to anyone. And it's again important to understand that in fact you never really hold the cryptocurrency. I mean, if you're buying a crypto, Ethereum, you never really have Ethereum. What you have is the private key that can unlock the funds that are on Ethereum blockchain. Okay, so remember, when you are buying Ethereum, you are not exactly buying that Ethereum. It's not an Apple that you go to the shop and you buy. No, you are having access to the private key, and you and only you is supposed to have it. Okay, so once you have that private key, it gives you a power to unlock the funds that are on Ethereum blockchain, okay, associated with that address. All right, so the private key is very important. And then and I forgot to say that for these contract accounts, unlike creating externally owned accounts, the contract accounts, once smart contracts, once they are being created and deployed, they use network storage. Okay, that's why it creates a cost. Okay, gas. I mean, you need to pay gas to create the smart contracts and deploy them on the blockchain, unlike externally owned account, because it uses network storage to keep information. It can be data, it can be funds, okay, whatever you send there, whatever your smart contract is designed for, but it uses a network storage, so that's why you need to pay gas, all right, to deploy a smart contract. All right, and then we continue and saying that, so once you have this private key, when you create a new account using a wallet, a random private key is generated. It has a length of 256 bits, and it's represented as 64 hex characters, and it's vital to keep it secure. Okay, again, very vital to keep it secure. Then after you have this private key, it uses something called how was it called? It's called elliptic curve digital signature algorithm. Yes, something like that. The algorithm, and that uses your private key. I mean, your private key takes your private key, uses this elliptic curve digital signature algorithm, and it derives the public key, generates the public key from it. Okay, so and each address has a unique pair of private keys and public keys. Okay, unique pair of private keys and public keys. And then on your account address, now your account address is derived from the last 160 bits of the public key, okay, and then hashed. So for example, if we go on here and if we click, for example, our wallet, like let's say you have created, if you watched our last video, you have created your MetaMask account, and then you have your MetaMask window open up here. You see your account. This is your account, which is derived from your public key. All right, the last 160 bits of your public key is being derived your account. And so basically whenever they say send me your public key or send me your account address, they use it the same way, because this account address is being derived from a public key, but it's not important for now. For now, you just remember that this is your your address that you can, or sometimes they call it, again, as I said, public key, but you can send this address to anyone you want. It's okay, all right? Actually, people must have this address to send you funds, but the private key associated with it, which you can check by going into account details and then export private key. If you click in here, you will be prompted to type in your password, and then you will see it. You always must keep it private, not to show anyone. Otherwise, whoever has it, as I said, then it will be granted an access to this account and then send the funds or do with them whatever they want, like steal it from you. All right, so that's all. Just for you to understand in this video about these differences in between types of Ethereum addresses. Basically, most of the users should only deal with these externally owned accounts, but as I said in the next video, we're starting to learn Solidity, so then we're gonna create smart contracts to deploy them on the blockchain, because our task is to create decentralized applications, and that's why we're gonna come, of course, across these contract accounts. That's what we'll be doing from the next lecture on this topic on, so get prepared for it. And the last thing, yeah, I mean, this is enough for this video. In the next short video, I will just show you how to get to the Etherscan and what type of information you can get from Etherscan. This is also very important. Something like called hashes. What are hashes, and how to prove to someone that you have actually sent your Ethereum to them. Some basic stuff, but most of you might find it a little difficult to do. So definitely stay tuned for the next videos. And yeah, guys, if you like the content, make sure to give the video a thumbs up, get subscribed not to lose any other upcoming videos, and thanks for watching. See you in the next video. Goodbye.